let's talk about cyclic groups. The link in the description will take you to related problems and some more notes. Cyclic groups are very simple objects. I'll start with an example. The simplest example is 0, 1, this set. So if you remember from the past lessons, a group is first, it's a set, and then there should be an operation, let's call it star. So a set and an operation such that these two together has some properties. Now we have discussed these properties in the previous lectures, so I will not go into great detail of it, but the highlights of those properties are closure. That is, if A and B are in G, then A star B is also in G. If and then we have inverse and identity. All these things are there, and the star operation should be associative. This is an associative operation, which basically means A star B star C is equal to A star B star C. I'll give you a motivating question here. Question. Can you tell me one operation that is not associative? That is not associative. Can you find an example of such an operation? Just for fun, you can give it a try and put it in the comment if you know the answer of this, or if you can find an answer of this. Alright. Now, what about this particular example, 0, 1? The operation is addition modulo 2. I have discussed modular arithmetic in a different video, but just to remind you, addition modulo 2 is a two-step process. You add the numbers and then you divide by 2 to find the remainder. And this remainder is the output of that operation. So for example, if I am adding 15 and 35 modulo 2, then I'll first add these two, which is 50, like simple addition, and then I divide this by 2 to find the remainder, and the remainder is 0. So 15 plus 35 is 0 modulo 2. That's the idea of modular arithmetic. And here, in this particular example, it works perfectly. So if G is 0, 1, if you add 1 and 0 modulo 2, you will get 1. You will get, if you add 1 and 1 modulo 2, you will get 0. And if you add 0 and 0 modulo 2, you will get 0. So the closure property holds because all of these outputs are inside this same set. That's the meaning of closure property. Not only that, this is a cyclic group. Why? Because I'll not go into the exact definition, technical definition. The basic idea is it can be generated by a single element. For example, 1 in this case. So if you start with 1 and then you add 1 to itself, then you get 0. Remember, we are adding modulo 2. So we found all the members of this set generated by 1. Generated by 1. I'll give you another example. Suppose G is equal to 0, 1, 2, 3, 4. And the addition, the operation that we have, is modulo 5. Of course, you can easily check that if you add any two objects of this set, let's suppose 3 and 4, then it will give you 2 modulo 5, which is again in this set. So the closure property holds, and in fact this set G is a perfect example of a group. Of course, you have to say both the set and the operation. So the operation is addition modulo 5 and the set is these 5 numbers. Now, this is not only a group, this is a cyclic group again. Why? Because you can generate all the elements of the group using one member of this group. So 1, let's start with 1. 1 plus 1, that's 2. 1 plus 1 plus 1, that is 3. And 1 plus 1 plus 1 plus 1, that is 4. Can you give me an example of a group that is not cyclic? Example that is not cyclic. Can you give me an example of a group that is not generated by one element? So that's, if you go to the 5th step, you will get back 0, which is all the 5 elements. So 1, 2, 3, 4, 5. You can create all 5 elements using a single element. But there are more generators of this group G. Let me write that. More generators. So if I look into this group G, the 0, 1, 2, 3, 4, 5. 5 is 0 again. 1 is definitely a generator. That's good. But there are other generators of this group. For example, this one. Let's look at 3. What is 3 plus 3? So we can start with 3 and then let's compute 3 plus 3. 3 plus 3 is 1. Because this is 6, but if you divide by 5 and compute the remainder, that's 1. That's the operation that we have. This is addition modulo 5. What is 3 plus 3 plus 3? Well, that's 4. Why? Because if you add 3 3s, you will get 9. Divide that by 5 to check the remainder. That's 4, right? Okay, then we have 3 plus 3 plus 3 plus 3. This is 2. You can check that. So you got 3, 1, 4, and 2. And then finally, if you add all 5 of them, then you have 15, which is exactly divisible by 5. So this is 0. See, you have found all the 5 members, maybe in different order, but you found all the 5 members of this set G, which means 3 is also a generator of this set. Question. Suppose we have a cyclic group of order 60. Order means the number of elements of the group. So number of elements of this group, cyclic group, is 60. How many generators? How many generators does this group? Yes. So that's a question. This is a problem from TIFR entrance. If you know the answer, you can put the answer in the description. More notes and more videos and remaining part of this problem is in the link in the description. Or if you are already in the Chinta portal, then just scroll down to find the next lesson in this sequence. Keep on doing great mathematics. Group theory is beautiful. I'll see you in the next video.